But ultimately, what is engineering? So you're very familiar at this point with drafting, right? And kind of how that set of the process works. And in a millwork company, um, that's kind of the first stage. A job gets awarded, a job gets handed off, and the first thing that happens after that is drafting. We do submittals, so we go in and draw the scope the way that we as a company want to be able to do that scope. But after that, there's a point where you need to be able to take those approved drawings and engineer them for production. And so the goal ultimately is to basically get an output that your shop is able to build what's on the drawings. And generally that includes programming for machines. And so what do I mean by machines? Well, there's a couple different categories of machines. There's CNCs, and within CNCs, there's nested-based CNCs or point-to-point CNCs. All of those are basically something that you take a piece of material on, and the CNC does routing or machining to either cut out a part or drill holes or the sort. But in addition to that, it's getting basically the drawings into where you have what's either cut lists or CNC programs or saw programs so that the parts can get cut out and then the people on the shop floor know how to put those parts together to make the products.
So why is there such a disconnect between drafting and engineering usually?
That's a good question. Generally, it's because a number of things. There's a lot of dynamic there. Because most companies do not have good documentation, do not have good standards documented to where the guys drafting know exactly how the guys engineering in the shop are going to want to build stuff. And so a lot of times there's work that has to be done separately from that. So let's say drafting has drawn something and they're using what information they have, right? So we've come in here and we have drawn either products out of our library. And so we're probably assuming that the products in our library are right. But there's a lot of things that have to be accounted for at the engineering stage. So one is, hey, did we draw using the right construction methods? But really, it usually is something like the materials have to be right. So it's not just the right thickness, but they have to be named the right thing. They have to be named for whatever that shop has to account for. So for instance, a lot of times it's the reports have to match what the shop is expecting the material to be called, or for instance, if they use like a automated material handling system, so it's depending on the company, it's very important that what you name the materials is accurate. How you do machining, what tools you're calling for. So if your library is not set up or you're doing some custom machining, or maybe you picked the wrong pole or something, all that has to be accurate. So if let me do a two-door base, let me place this next to this. The product numbers have to be done right. So like when I get done with drafting, I'm thinking about a totally different set of things than I might be thinking about when I'm engineering. So when I'm drafting, I'm thinking about, hey, did I get the scope correct? Did I get the size of the cabinets correct? Did I get the material finishes and the finish schedule correct? But most of the time, you're not necessarily thinking about, did I get them right in the material in the Microvellum spec groups? And even then, I might be trying to get them right, but not to the level of what is needed. So say all I had were these 3 cabinets, and I got this drawn. Let's do my elevation, just kind of take this through the full. All right. So I've got my 3 cabinets. And I should have a filler on either side. So let's put that in. Let's do a left side wall filler of 1 inch. So now I've got my filler there. It's showing up here like I want it to. Let me see if I did this right. So let's add a filler over here. So now it's time for engineering. We've got field dimensions back, right? We've got some red lines back. So maybe the architect's red line said, I don't want these to be PL1. I want them to be PL2. Well, that's something the engineer has to change. Say this room is actually room 101. and the drafter didn't number these products, but at this particular shop, they like to number their products with a room number. So I need to do that. So I need to go and modify products. I need to renumber my products. So now I want them to be 101.01 is the first one, and then I can renumber them and it'll do the sequencing for me. So there's that. Some places also like to put some information in the product comments. So they might want to put things here. For example, like they might want to say this is in break room 101, elevation A. I don't know. Different companies have different information they put in there, or they might put the finish in. So that's something. And then actually product comments have the ability to break things up. There's actually 3 comments. And so some shops have standards for that engineers do that drafters don't ever either get taught or trained on. Like, did I assign it the right spec group? So that right now I don't have spec group set up. I would need to set that up. And then maybe drafting match the architecturals, and then engineers get in there and say, well, we don't build doors 36-inch wide. That's wider than AWI requires. So now we have to go back to the architect or to the client and say, hey, we shouldn't have drawn it this way. This should actually be a 2-door, or maybe I need to just, they want 4 equal doors. So then I need to adjust these. So there's ways you can do that. So for instance, maybe I got field dimensions, and so you have to, when you change something for field dimensions, you have to change your walls, you have to change your cabinet sizes. A lot of times you have to change some 2D stuff to make it print correctly again to get to where this is updated, right, for what I want. So let me just get rid of that. So maybe this shop, they actually put in products for their fillers. A lot of shops have a separate filler product. And some shops just put this in the spreadsheet, meaning they don't use it for drawing purposes, but they just put it in so that they have those parts in the work order. So I might put them off here to the side. And that is because a lot of times that they're just sending a loose part that in the field, they're actually going to what's called scribe it, cut it to fit. So they're going to send an oversized part that in the field, they're just going to cut these to fit once they get the final dimension they need there. So every shop is a little bit different, you know. So say I did want to change these sizes. I've got here to be 4 equal, and then I could do a bump product, modify products. So I'm going to bump that, what's called bump this product to that product, and then resize this one. So there's lots of little changes like that that can come up that have to be done at the engineering stage, right? And then all of that ultimately is to then, okay, I've got drawings that are accurate now. I need a spec group set up. So let's go do that. Rename, let's call this PL2. We said the architect revised and said they want this to be PL2.
But we should usually create a copyright, or
Yeah, usually you would create a copy. In this case, you might have to go in here and select a different poll or a different slide or something that maybe didn't get set up. So then I have that, and I'm going to redraw these products.
So there are some, once you go into a prompt, there are some values that are highlighted red. Those are pulled from global variables, right?
Usually they're definitely formulated to look at something.
So are those type of values, are we okay with modifying, or are those set up like that for a reason?
It depends on the client or the library. Like here, you can, if you see that, that just means it's formulated, and you can right click show formula to see what it is. But usually if it's editable, it's intended to be able to be edited if needed.
Okay.
So now, remember I added this one, it renumbered it correctly, but now then usually you'll go into your product list when you're ready to process. And so in here, I can see all my products. And so remember, we added these product comments. So if that's a standard, a lot of times, each company might do this differently, but say that was a standard, I could usually edit all these at the same time. So then you're going to create a work order. But usually when you create a work order, it takes a little bit. So there's a tool that I like to use, because a lot of times what happens is you'll create a work order, you'll find a mistake, you have to go back, correct your mistake, and then reprocess to make sure you fixed it. And usually that's to get your parts list. Well, Microvellum has this tool, parts list review, that basically creates your parts list like your work order has. And so we can actually do that and check here ahead of time all of our parts and materials and edge banding and stuff. Group them by my product so I can see by product and by material. So item 101, this is my two-door base. And so I can see on my, this is 1/4 inch material. And so every client, their material names might be different, formatted differently. But yeah, so I can see, do I have the right sizes? Do I have the right material? Do I have edge banding? So this is your edge banding. So what this is telling it is it's going to cut the left slab. This is your finish width and length, and this is your cut width and length. So what's the difference between those two? Well, your cut width is like if it's coming off the CNC or the saw, if it is accounting for, like in this case, we've got 3mm thick edge banding, it needs to undersize your part so that when it puts the edge banding on at that thickness, it's going to end up at your finished size. So like this is the part size in Microvellum, and then when it process, it deducts the edge banding from this. And actually, if you do pre-mill, so if you think like you cut a part off the saw, it's going to go through a machine called an edge bander. And what that edge bander does is it glues on edge banding, which has a thickness. But some edge banders also do what's called pre-mill, where they shave a little bit of material off to clean up that edge before it glues it back on. And so if you think about, okay, if I need to get to 30.25, and Microvellum needs to account for the thickness of the edge banding as well as the thickness of how much the edge bander shaves off. And so it does all that math here so that your cut width, basically what the saw cuts, is exactly the right amount. So when it goes to the edge bander, the finished size will be this. Does that make sense?
Yeah, so how do you set up the pre-mill amount, or is that based on the model of the edge bander machine, or what?
Yeah, it's based off of that, how that company uses it. So the pre-mill amount is an adjustable setting in most edge banders if they have it. And it actually has like a cutter head that will cut material off. And so they can decide like how much material they want. And whatever that setting is usually set in your tool files. So
And do they use the pre-mill because the CNC doesn't like cut it perfectly, or what's the reason why they need that?
yeah, exactly. So usually it's because particularly on like certain melamine materials, the CNC, if you think it's a, or even a saw blade, it's cutting, and that melamine, that face layer can chip really easily. And so even though it might have a clean edge, the face will have little tiny nicks in it that show the core. And so that pre-miller actually just cleans up that edge. So it's really clean. So when they glue the edge banding off, there's no chips behind the edge banding that look bad.
Okay.
So it is like a really fine cutting bit that does that. And so that amount is a setting in your tool file. So here it's 0.02, essentially 0.5 millimeter is where you set it to. And that's like global across Microvellum once you set this here. So every company again sets that differently, but it works the same way. If you use pre-mill, you have a set amount that it's set to usually. And then what Microvellum does is it takes your finish size minus the thickness of your edge banding plus the pre-mill amount. That's your cut size. Does that kind of answer your question about, like, you asked first, why are drafting and engineering usually on such a different, not the same page, right? And one, they kind of have different purposes, but two, generally, like, they are different levels of training of people that have maybe come into the company at different stages. And most companies have never truly sat down and defined their standards and documented to where it's like, hey, we always do fillers this way. We always do cabinets. You know, it's usually very much cater to your client, cater to the project. And that means there's decisions that have to be made. And depending on who is involved in those decisions, they might be made different from case to case, which leads to then it gets to engineering, and the engineer or production maybe says, well, that's not how we want to do it. Change it.
So is that something that should be set up in the Microvellum products? Like,
yeah, ideally as much as possible. And so that's where having a like Microvellum and having a library that allows you to one, define those as much as possible and build the options in so that instead of having to know what tool do I need to use or what spacing, like that's built in. All you should have to do is just pick what type of job is this? Are we doing, Euro hinge versus institutional? Like you're giving kind of user-friendly options that make, and the decisions are made already related to those options. But that is like at a high level, once you do that though, so say we are ready to create a work order from these, you can do that here from the product list, which is, one of the ways I would usually do it. And you can select your products and say up here, create a work order from selected products. And then each company is going to have their own standards for, how do they name their work orders? Do they fill out any of these other fields like the comments, for example? What options should be checked here? And that's, specific to that company, but generally you're going to name your work order something, with the job number and whatever that company uses. And you can see here also what I've selected here. It's showing me the products. Okay, it's going to include these 4 products, which I can see the name, the quantity, and the item number that I've given it. And they're all in this room. So if I had multiple rooms, you might see the other rooms and the other products, but you could also confirm here, hey, are these products in the room that I expect them to be in?
is there a max quantity of rooms or a max quantity of products that we should stick to?
That's unique per company as well. A lot of companies try to work towards what's called smaller batch sizes, saying like, hey, like a limit of how many products per work order. So it gives you here a quick summary. Hey, this is what you named the work order. There were 4 products. No buyout. So what buyout, as far as Microvellum is concerned, is if you label a part or a product or something as buyout, it means like it's going to include it for quantities, but not for processing the parts to your machines, because it's assuming you're going to buy those parts from an outside vendor. In those 4 products, you had 35 parts. So yeah,
so
I want to go ahead.
Does it include like pulls, hinges, or is that?
Yes, it should. Yes, those are going to be included as hardware. So when we hit yes, this is similar to what we looked at before. Here's our parts list. So you can sort, you can group, and then, again, here we're going to confirm, okay, do we have everything on the right material? And this is where you might find mistakes and say, oh, shoot, I didn't set up, my name of my material correctly, or I didn't assign something correctly. You see, do you have your edge banding set up, or do you have the right edge banding assigned to each part? So here's where you're going to kind of check with a fine-tuned comb, because what this is actually doing is these are your exact parts that are going to get made. I'm going to optimize. So here, to be able to see it, I'm just going to pick the nesting. So it nested these parts by material, but here's all the one-sided material. So these are our doors and our filler. So it nested these together because they're both on the same exact material. So my doors and this filler are both the same one-sided material. Now, I didn't have this set up to be perfect grain. If I had, then it would have probably put the 2-door cabinet, the 2 doors next to each other on the nest so that the grain spread across them. But here I can check things like, okay, it's got, my part size is correct. It's got my machining for my poles, my hinges, which it looks like is probably drilling. But in here, you can see what this means is V-bore is a hole, vertical bore, Z0P5. So that tells me the depth that this is going to drill, 0.5 inches. And then the diameter of the hole is the diameter bit it's going to use. So I can go and look at each one, same. Like this, where it will optimize and figure out how to place all the parts optimally on a single sheet. So it does all this thinking and aligns them so that basically this program, you'll put this sheet of material on the CNC and it'll cut and do all this machining all in one process. Now, separately, a lot of shops will do what's called saw and then point to point, where it'll cut out parts like this on a saw, but it's only cutting rectangles. And then they'll have to take each individual part to a separate machine to do all this face machining. And that's what point to point is like this, where you have each part by itself and you're going to put this on a machine and it's going to do, like, the rectangle's already cut. And so it's going to do all this machining separately on a different machine. So like here, if this rectangle was cut on the saw, which can only cut straight lines, then on the CNC, they're gonna take this part, put it on a CNC, and it's gonna route this, it's gonna route that, it's gonna drill all these holes. Does that make sense?
Yeah. That's a side panel, right?
Yep. So this is like the same cabinet side, just about.